Now we refer to question number 7. Notes question number 7. Law of conservation of angular momentum. So now there is a chance, opportunity that in case you miss something, linear momentum. Yes. For linear, and here it is rotational. For linear, yes, law of conservation of momentum. Anyone? Total momentum of the system remains constant if, yes, if there is no external force acting. So in linear, it was, if there is no external force acting, then force is equal to what? Rate of change of momentum. Differentiation of something 0 means that thing is what? Constant. What is this? It is linear momentum. That means total momentum of the system remains constant if there is no external force. Equivalent to this, if something is in rotation, first step, equivalent to force, yes, torque. If there is no external torque acting, torque is equal to what? Rate of change of angular momentum is equal to 0. L is constant. What is L? Angular momentum. And in application part, L, P was equal to what? P was equal to mv. L is equal to what? I into omega. So in a system, if I increases, omega decreases. If I decreases, omega increases. I, omega remains constant. Time with you is 3 minutes. Now we take up examples. For I into omega remains a constant. Example number 1. Here in the notes it is example number 5. Person carrying dumbbells in his hands means what? The initial position. See, this is the initial position. The person with the dumbbells in hand. Dumbbells are at a distance. Is rotating at certain angular speed. So if the person draws the dumbbells close to the chest, mass is close to axis of rotation. R decreases. So moment of inertia I decreases. Omega will increase. So that means if a rotating person draws the hands towards the chest, the speed of the person will increase. Diagram for the same is, say a person with the dumbbells in his hand. This distance is, say, R. This is the initial diagram. And after some time, the person draws the hand close and the dumbbell's new position is this one. Say half of R, R by 2. So for this particular case, I into omega remains a constant. I into omega is constant. What is I equal to? I is equal to m into r square. R decreases, so I decreases, omega increases, and the product of the two remains a constant. 2 minutes to write. Draw the diagram. 2 minutes to write. Example number 2. In the notes, this is example. Example number 2, yes, same. Tornado. You might have seen Discovery or the movie. Yes, anyone who can explain the phenomena. In tornado, the wind starts moving in a circle and it is like this. It is in form of a cone. As you move down, even for a mixer grinder also, you will see the fluid in motion, the inner layers are at very high speed. From this point to this point, this is R, this is R dash. I into omega remains constant. As you move from this position to this position, I decreases and omega increases. 2 minutes to write. Example number 2. So when this tornado, fast moving air, suppose you get a house at this position, it will split the walls into pieces, bricks, and will set it in a fluid form. It has so much of energy that it can take a house, complete house in its trap, and all the bricks start moving at a furniture, everything in house starts moving at a very high speed. This is the effect of a tornado. Then we have some more examples. I will just write, draw the diagram. One example is for a dancer. Yes, ballet dancer. How a dancer can control the angular speed. Yes, if a dancer is moving, rotating at certain speed, arms are wide. If the dancer brings the mass close to the body, then moment of inertia I decreases, omega increases. So that the dancer can control this mass. That means dancer can control I, so dancer can control omega. In your words, write 2 minutes how a dancer can control angular speed omega. Helicopter, cabin, blade. Suppose there is only a single blade. Fine. If this blade rotates clockwise, as per law of conservation of angular momentum, the cabin will start rotating in a anti-clockwise and the pilot is inside the cabin. So the pilot will also start rotating. That is why either you need to have another propeller or you need to have another mass here. If the blades rotate clockwise, this mass will rotate anti-clockwise. So that angular momentum remains constant and there is no rotational motion of the cabin. So this is helicopter. Then diver or a cat. A diver will dive, say this is the height of the person. As the person moves, person can bend the body like this. So this is the position. Diver is in a standing position. As the diver dives at the person is in air, person can, yes, fold his body so that person can decrease moment of inertia. If the moment of inertia I decreases, yes, I into omega is what? Constant. I decreases, omega increases. That means person can have more rotations before touching the water. That is how a person can control the rotation. 2 minutes with you to write. 2 minutes to write. Yes. The purpose is different. To control upthrust and motion along x-axis. The purpose is different. Numerical. Numerical number 11. Yes. Question is, a boy is seated in a revolving chair revolving at angular speed of 120 rpm. Page number 5 by 84. By some arrangement, the boy decreases the moment of inertia of the system from 6 kg meter square to 2 kg meter square. What will be the new angular speed? You have to find out new angular speed. What is given, what is required? Yes. Initial angular frequency, you can say, how much? 120 rpm. Second one you want to know. Yes. Moment of inertia initial 6 kg meter square. Final moment of inertia 2. Somehow the person on the chair has reduced moment of inertia. If you want to draw a diagram, you can think of initially it was this one, now it is this one. Mass has come close. Concept or the formula, I into omega remains a constant. So I1 omega 1 is equal to I2 omega 2. Solve it. Find F2. I1 omega is equal to what? 2 pi f is equal to I2 2 pi f2. I1 is how much? 6. 2 pi cancel. F1 is how much? 120 rpm. I2 2. Find F2. Yes. 6 by 2 3. 3 into 120. F2 comes out to what? 360 RPM. For competition purpose, yes. You can come out with the answer within no time. Competition. This is the way you need to think. I omega remains constant. So I is how much? Initial value was 6, final is 2. I is 1/3. Omega is how many times? 3 times. So initial value was 120, the final value is 3 times. How much? 360. I into omega constant, I 1/3, omega 3 times, or frequency 3 times. Numerical number 10. Question is, the sun rotates around itself once in 27 days. Time period is given. If it were to expand to twice, underline twice, its present diameter, what would be the new period of revolution? The concept remains same, no change. Initial status, radius r. Final status, you can say R1 is equal to R0. Second case, dia is twice, means the radius is also 2 times. Solve. 2 minutes to solve. Time period. Omega can be written in terms of time period? Yes. Omega I1 2 pi by T1 is equal to I2 2 pi by T2. I1 I2 ratio T2 by T1 is equal to I2 by I1. I2, second case, mass remains same, M and M. What is the moment of inertia in the second case? M into R square. Radius is 2 times. So moment of inertia in the second case is 4 times. Radius is 2 times. So moment of inertia is 4 times. 4 by 1. T2 is equal to 4 times T1. What was T1 equal to? Yes, first case, 27 days. T2 is equal to 4 into 27 days. Yes, 108 days.